good day. What a good day in January as we are preparing to open schools. Right. Today we want to talk about change in momentum. This is grade 12 physics. So we are saying the vector nature of velocity determines the vector nature of momentum. Right. And the velocity and the momentum of an object are always in the same direction. So when the mass and the velocity of an object remain constant, the momentum of the object, it also remains constant. Remember, we said the momentum is the product of mass of the object and its velocity, and it's represented by P, which is equals to M times V. Right. So we are saying when the velocity of an object changes, right? When the velocity of an object changes, the momentum also changes. And the change in the momentum is the difference between the initial momentum, right? And the initial momentum is represented by, when we are writing initial momentum, we represent it as P initial. This is what? The initial momentum. And then the final is represented by PF. This is the final momentum. And remember, momentum is the product of mass and what? And velocity. So both the initial momentum and the final momentum are vector quantities. You are supposed to know that. The initial momentum and the final momentum, both of them, they are actually vector quantities because they have got magnitude and direction. It's different from mass that has only got magnitude, or speed that has only got magnitude. So we can write the relationship in the following way. We can write the relationship as a change in momentum, right, is equals to, right, the change in momentum is equals to the final momentum minus the initial momentum. Right. So we are saying change is represented by a triangle in what? In this momentum. So we can write this PF minus PI. Right. So this is the formula. This is the relationship that we have for momentum. And we can illustrate, right, the relationship between the initial momentum, the final momentum, and the change by a vector diagram, right? Vectors, they show relative magnitude and direction. And again, we can make the final momentum subject of the formula. The way we solve equation, we can now say PF is equals to change in momentum plus initial momentum, right? And again, we can make the initial momentum the subject of the formula. Pi, right, is equals to the final momentum, right, minus the change in momentum, you see. So we can write these equations in the terms of the final momentum, and again, it's a vector sum of the initial momentum and the change in momentum, right? And if we want to draw a vector diagram to represent the change in momentum, we can draw vectors for the initial momentum and the final momentum in the exact direction with the relative magnitudes, like those lengths, right? And then finally, we can draw the change in momentum so that the final momentum is the resultant of the initial momentum and the change in momentum. For example, let's say there is a car with a mass of what? Of 600 kgs, right, travels in an easterly direction along a straight line, a straight, let's say horizontal road at a constant velocity of 20 meters per second, right? And the driver suddenly increases his velocity to a constant velocity of 24 meters per second and continues to drive in the original direction. And then the question says, determine the change in the momentum of the car. So we are saying P is equals to what? mv, right? And then I, this is the initial momentum, and then the final is mv final. So this one is going to be 600 kgs times the positive direction of 20 meters per second. And then this one we're going to get what? Positive 12,000 kgs per meters per second. And then the final is going to be 600 kgs times positive 24, right, meters per second. And this one is going to give us what? 14,400 kgs per meters per second, right? So the change in momentum is going to be like what we said, right? The final momentum minus the initial momentum, which is going to be what? 14,400, right, kgs per meters per second minus positive 12,000 kgs per meters per second. So this one is going to give us a positive 2,400 kgs per meters per second. So we are saying now the car, right, there is the change in momentum of the car is 2,400 kgs per meters per second, right, in an easterly direction. Remember, the change in momentum is a vector quantity. It has got magnitude and direction. So that's how you tackle such a question. So we are saying there is a car with a mass of 600 kgs and is traveling in an easterly direction along a straight horizontal road, right, at a constant velocity of 20 meters per second. And then the driver suddenly increases his velocity to a constant velocity of 24 meters per second. So you say the driver is increasing the velocity and he continues to drive in the original direction. So we want to determine the change in the momentum of the car. So you see that like the car is in the same direction, right? So there is a positive increase in the eastern direction, right? So how can we draw the vector diagrams? So we now want to draw the vector diagrams. So when you want to draw the vector diagrams, there is this initial, right? So this is P1, right? PI, the initial, and then the final, you see. That's how we draw the final, P final, and then you draw your change in what? In your momentum. Your change in your, this is now your final momentum, right? So I'm sure we are together there. So that's how you illustrate these changes in momentum diagrammatically, and how you also use these equations to answer such questions. So for all those who need help in physics, you can contact us on our email edwardteach@gmail.com, or you can check us on YouTube or on WhatsApp, the same name, Tichaona Edward, right? Or you can call us or WhatsApp us on 078 196 5544. We are in South Africa, Cape Town. Thank you so much. Have a good day.